Again, people are, okay, we're back online. So I thought we would go through this creating a new planet document quickly that Chris Colo has created, and therefore you can ask questions about things that you find in the document that maybe are not clear or that we could do a better job of. And Chris is in the audience, so he can also help us out. Several people in this room claim that this is a useful document, so let's find out. I'm sure it is. As Chris points out here, the default starting point for a new simulation should probably be the P1SOM40.R run deck. And what do you know? You all have run at least the first hour of this run in the Planet 1.0 branch. And as he points out, it's a 4x5 model with a 40-layer atmosphere. And he doesn't mention it, but it has a 32-layer dynamic ocean. And then he mentions some of the other templates that you can use that are related to, as you know now, Q-flux oceans are prescribed sea surface or fixed SSTs, fixed sea surface temperature oceans. So this step you know very well. In your Model E Dex directory, you can type this command. So we can go down here into this window. Now, run name, you can make it whatever you want. You can name it, I don't know, cat, dog, anything you want. But I recommend making it something that might be somewhat descriptive if you can come up with something like that. You know, before we use P1SOM40_test, but this can be my test 2, for example, just for fun.
You make your zombie planet.
Yeah, zombie. D1 or D2 or D Steven 1.
Model there, I guess. Nobody did it yet.
Yeah, model. Yeah, we haven't done that yet. Okay, so that will run a run deck, and the run name or run ID in this case, as we keep calling it, is this P1SOM40_test2. That is the run name or run ID that we have created. As Chris points out here, if you need to modify planetary gravity, radius, mean surface pressure, atmospheric composition, etc., you should follow what he says A below. If you're not doing that and you're just changing orbital parameters, those are relatively minor. There are ways to skip A and jump directly to B. Before we do that, I want to mention one other thing. As I pointed out earlier, I think I pointed it out during the tutorial. I hope it wasn't in the offline discussion. But for several of our papers for which we have used ROCKE-3D, we have published not only some of the model output, but we have published the run decks and all of the input files that go with those run decks. So, for example, those are, and you can find the location of those at the bottom of our papers. But in essence, they're sitting on this repository to which I've just gone to just now. In the directory called Publication Supplements. They're also sitting on archive.org, archive.org, not the infamous prepress. And if you go down in here, you can find some ACC files, AIJ files, input files for different kinds of oceans, because in that paper we had different kinds of oceans, and you can find run decks for different kinds of oceans too. And this says all the run decks we used for this giant paper that we wrote last year, or that I should say we finished writing last year, because it took us about 5 years to write that paper. So let's say you want to use one of those run decks for your run. All you have to do is create a new run deck like this, and then you can copy this name into that run deck name. Okay? So you can just take, one of these, download it to your computer, and overwrite this P1SOM40_test2.R. You just copy this name into that name, because everything will work. All that stuff will work. And then you'll have to bring your input files over and all that kind of stuff that will go along with that run deck, which are sitting in here. Just so you know how to do that. Okay, let's go back to Chris's document.
Why are you asking to overwrite something? You can just download and use it.
Yeah. You can use any name, including overriding.
Yeah, but the symbolic links won't be created.
Yeah, but
You can do it later.
yeah, but everything will be created.
It's a way to do it. You can do it however you like.
No, once you get the file with real run deck, you don't need anything else.
You have to create those symbolic links, okay? If you don't make the symbolic links, you cannot do it.
No, make setup will create all the symbolic.
It will not create this. It will not create. Okay, well, we can. Okay, we can. Okay, fine.
There should be links to this directory that you just showed in your papers.
Yes, at the bottom of the papers in which the documentation was put up there. Okay.
Usually should be in acknowledgement.
I was just pulling up one of Michael's papers and I didn't find it.
Well, the climate's one paper, it'll be in there, and in the Proxima Centauri B paper that Tony led, it's in there also at the end. Okay.
In the moon paper.
Did we put the files up there for them?
No, not yet. But the link is there.
All right. So as Chris points out here, if you want to modify planetary gravity, radius, mean surface pressure, or atmospheric composition of major constituents, you should follow A below. So let's say we want to do that. So as he says here, you first have to edit the file planetparams_mod.f90 in model E model shared. Well, we don't have a model E directory. We have a model E2_planet_1.0 directory. So you go into model, you go into shared, and you just edit this planetparams_mod.f90 file. And as he says here, and we showed this file yesterday, there are various planets already in here, including one we call like Mars, which has Mars gravity, radius. It has the air's molecular weight, in this case it's pure CO2, and the CP over CV variable that we call SRAT in the model. He says there should be a planet in here called not Earth. Let's find that. If you're online or you're on your computer, you might want to check these things to make sure that you see the same things I'm seeing. And you can see that not Earth is basically Earth. It's just a template for you to use. So the first thing you would do if you want to create a new world is change some of these things that you're interested in for the science of interest. So he gives you some examples of how to change things like M-air for a given atmosphere. So I can just copy this. Let's see, one. So I'm just going to make a copy of this. Oh, I didn't stop there. So now I've made a copy of that, and I'm going to call this not Earth 2. Okay. I can keep everything else the same, but let's say I want to
You
zero.
have to change it in 2 times.
Yeah, sorry, you have to change it 2 times. There, you're right. Let's say we can just keep it simple. I don't know if Chris, oh, he gave you a nice example here. Here, let's take this one. For something like an N2 90% and CO2 10% atmosphere, PAR and PO2 can be set to 0. So let's try that. Just what he says here. So we'll set PO2 to be 0. We'll set PAR to 0, and we'll set PN2 to 90%. Then you'll have to change the mass of the air, and Chris tells you here how to calculate the mass of the air for this particular mix of gases. We'll set the CO2 somewhere else. So you have to change M-air to 29.61. He does not tell us how to change SRAT, unfortunately. That's an oversight on your part, young man. He says it was, okay. Well, we leave that alone for now, but that should also be changed in the model. So we won't mess with the gravity or anything, but he gives an example of how that will look. And then we go down to the run deck and where you have to modify it.
If you want to change P-surf and P-top, usually it's a good idea to leave the same scale. I mean, like if you increase or decrease like the surface like 10 times, then you should do the same with this p-top. Just
Yeah.
dump.
Yeah, let's say you want to use the 10% of the atmospheric pressure.
Yeah.
You would change them accordingly.
But
Keep that in mind.
P-top is the lid.
it's no, it's where sigma layers switch to pressure layers. So it's basically
To constant pressure.
Yeah, to constant pressure layers. So it's, I guess, about like tropopause, I guess. Sometimes you want to lift it above if you have very high topography. You don't want topography to penetrate that p-top. So if you have topography which is very high, sometimes you have to lift this p-top and make it smaller.
Okay, so we did that. Then we go back to our run deck that we created before, and I have to change a few things there. So we mentioned that this planet params now has to be changed to not Earth 2. And then he says here, you should also add the following somewhere underneath the parameter section later in the run deck. And that is related to the calendar stuff that Tom mentioned. So I don't know if it's in this file. No, it won't be. So we just go here and we add it. And we write planet name equals tick.earth2. Now, be very, very careful about single quotes in this run deck file. Sometimes people copy from Word documents, other things like that, into these documents. And Word, when you copy that into other editors, often uses a different kind of tick mark. So make sure you actually replace those tick marks with the normal single quote from your keyboard. If you don't, it will say it cannot find this file or cannot understand this variable, and you'll have a really hard time figuring out what on earth the model is complaining about. One of the benefits of having more than one kind of tick mark.
Where was the other place we changed not Earth to not Earth?
At the top. At the planet params.
Oh, yeah. It's not that.
Define planet params, not Earth 2.
Okay.
So those are the two places you want to change that stuff. Now, what Chris has here about quantized year length is probably not true. You also want to set it to true for totally locked worlds, but in general, unless it's a very slow rotator, as Tom said, you should keep this value set to true. So we should put that in here just to make sure the model does that. You can see that I'm making sure my tick marks are correct. And if you want to change things like orbital parameters, you will do that here. So for example, let's just use these examples. Let's change these things. Copy that. Okay, there we go. I'm going to put these things in for the orbit. So I'm going to say, I don't want Earth's eccentricity and I don't want Earth's liquidity. I'm going to make them 0 and 20. I will keep my sidereal orbital period, that's the length of the orbit in seconds, 365 days. We will leave the hour angle offset equal to 0. That's the default anyway. And my sidereal rotation period, I've left at 24 hours. But of course, I can change that. If I want to make it 240 hours, I just add a 0. And it can be negative for retrograde. So when we run modern day Venus, we figure out how long the sidereal period is, and we just add a negative in front of this number.
How do you do that by changing liquidity to 90?
It could be like 180 maybe.
Is it equivalent?
I don't remember.
Like 180 of liquidity is 0 with retrograde.
Yeah, exactly.
I don't know if it'll work in practice.
I don't think if anybody tried it.
Anybody's tried it. That's the answer.
Probably don't try.
it's easy to verify, right?
Yeah,
You
yeah.
have to do 2 experiments.
Yeah.
Yeah, that's right.
180 0.
So as Chris says here, this hour angle offset parameter only needs to be used in cases where one wants to modify the placement of the continents for a synchronously rotating world. So by default, the substellar point for a synchronously rotating world will be over the Pacific. And if you want to do a configuration where you want to put the substellar point over Asia, you have to change this hour angle offset to that number, the number of degrees from the timeline of the Pacific. Pretty straightforward. I won't do that now. As he says here, again, remember to set planet name equal to something in the run deck, or else your run will be in Earth orbit. If you do not set this in, you will end up with Earth orbit. I think even if you set all these other quantities to non-Earth values. I can't say that I have verified that.
That's what Tom claims.
Yes, that's what Tom claims. Yes, exactly. I've never tested it.
Planet name in there. Right now, the Socrates paths are still commented out. Is that going to cause trouble? Like, does it have a default setting?
We have given you directions for that in the guidelines for setting it. You have to change that stuff. We discussed already in the setup document.
Okay.
Now he has a line here for synchronous rotation, sidereal lower period equal to sidereal rotation period. You may also need to add the following line for close-in orbits. I would say, please don't do this. It can cause other problems, and we don't want you doing that. But when he says sidereal period equals orbital period equals sidereal rotation period, don't set those variables to those names. Just use the same number. So, just pointing out. Then we have this planet underscore S0. If I want to change my installation, you can see here that it's commented out in the section. So let's say I want to make it larger. I can make it 1500 watts per meter squared, but I have to comment it out. If you don't comment it out, it will take the default Earth value. Yes, and he says this comment here, when simulating actual planets, you will need to change both planet S0 and the sidereal orbital period for consistency, keeping in mind Kepler's laws. We assume you understand Kepler's laws. The model does not do Kepler's laws for you, because sometimes people want to do simulations where they want to violate those for whatever reason. So we expect you to understand astronomy 001. Not 101, 001. If you need help,
If you do a series, this is what you could interpret. You do a series of planets in different orbits around a star, and they're synchronously rotating. So the orbital period changes, then the rotation period will change along with them. But you're also moving closer to the star, so the incoming starlight is changing also, and you get different climates because you want to know how much that change in climate is due to the change in rotation period, and how much is due to the change in insolation. And then you might want to do idealized experiments where you just change them separately and hold the other one fixed. And it's not physically realistic that it isolates one effect versus the other.
as he says here, later when you generate your output files, including your AIJ file, which you can generate with the command scale ACC, you should check INC SWTOA to make sure that you get the number that you expect to get. So that this planet underscore S0 is equal to that value that comes out of INC SWTOA. There are a few additional tweaks you can make. As he says here, these lines may not be necessary, but should be added to allow for flexibility in the temperature range the model expects to see. This is really if you're pushing the model outside the bounds of what a normal Earth model would be. We have certain, what would you call them, bounds that we put on different physics in the model on the Earth side, so that if the model goes outside of those bounds, the model will crash and tell us, for some reason, this planet is the ground is very hot, or for some reason the ground is very cold. For us, we often run into those problems because we're often forcing the model with more insulation or less insulation. So in that case, we often try to remove some of these bounds. So for example, here, we have changed the values for what the min ground temperature and max ground temperature bounds are. So I would just add those into this section of my run deck, or just underneath the planet S0. You can put it anywhere in this section of the run deck, in this parameter section of the run deck. Yeah. Okay. Then he says, this is also useful. Initial pre-surf from topo equals 1. Not strictly useful, but useful avoiding crashes when applying alternative topography, aquaplanet setups, etc. These are things you will find.
To be honest, I guess 400 Kelvin for ground temperature is kind of on the bounds. I mean, you don't want to boil water on, unless you have higher pressure. Then
Yes, it'll be at higher pressure.
probably it will work.
Probably this number should be less than 373.
Yeah.
We can put that in here to make Igor happy.
Are the units always Kelvin? Because the output is sometimes Celsius.
Actually, no, this is Celsius because it's minus 200. So yeah, so it's not 300.
So you need to make it 80 or something.
As you've mentioned, that it's not, the temperature shouldn't be just boiling water. It should be, when does water become an appreciable part of your atmosphere?
Yes, also.
And that's really the red zone for this model.
No, that's a different thing.
Yeah, but from the point of view of ground hydrology, I guess it will just go crazy if you go like above boiling point.
You could have water in the soil and have a dry atmosphere, basically one of these very dry Abe planets. And if the soil gets above 100 C, you're going to have problems in the model. That's what he's saying.
So actually, I never thought of this, but isn't this Kelvin though? And I just took this from your old one.
It can't be Kelvin if it's minus 250.
I mean,
actually,
it can be though,
I
right?
think it is Celsius because it comes from the ground hydrology, and ground hydrology works in Celsius just because it was.
Don't expect consistency in our model.
So it really shouldn't be anywhere close to 400 then.
No, it should be. He probably took it from
your run deck.
one of my run decks from 5 years ago. Yes, I'm to blame. Any problems you can see?
So yeah, it is in Celsius, and the default value in the model is 130.
Okay.
No, 130.
I mean, I think the point is just to make them so wide that the model doesn't crash for this reason.
Yeah.
Okay. Our ground person is surprised by the default value being 130. Anyway,
It doesn't matter.
Let's move on.
That's only an example.
these other things I'm not going to add or talk too much about. They're in the crash document that are fixes to the model if things don't work out. They're usually because you've changed the topography, or again, you've done some kind of forcing to the model that goes outside of its normal happy state. Then there's things like composition. Again, we've already talked a little bit about the composition and how for this particular one, we're going to run with 90% N2 and 10% CO2. So hopefully Chris has the numbers down here for that. So in this case, I guess you created your recommendation was to create a separate GHG file, right, Chris?
Yes.
And so he has, although he doesn't tell us what he's put into that file anywhere, have you? No?
I don't know that I put an actual file in that.
No.
Are we?
We have to do that. So we have to go to the GHG file. Here's the default file. So you have to put a new file in there. And as we've said, you can put that file in your direct path, in your own path if you put the full path. So I can just say P1 SOM40 underscore test2.txt just for fun.
Are you on
the line above?
Yes, I'm getting.
Are you on your Apple or on Discord?
I'm on Apple. And then I will have to create that file. I will have to locate hg.march 2009. I'm going to copy. To And then I go into that file, and as we said, I only need one line in this file.
Where do they live again?
Yeah, they should be in your prod input file before. If you've run the model before, it should be sitting in there, GHG file, and it is in this case. And then you have to figure out what to put in here. So we're only going to have N2 and CO2, so I zero out these other quantities.
Careful with the columns.
Yes. And then I have to decide now. Sorry? I don't think it's not fixed. I've used.
That would be too much.
No, because this value is going to be very large. They can't be fixed. So now we have to decide how much CO2 to put in. I want 10% of a 1 bar atmosphere.
By weight, not by volume.
Doesn't matter that it's 1 bar.
It's 1 bar, so it's the same difference.
It doesn't matter that it's 1 bar.
Wait, what?
Wait, what? Yeah, exactly. So we want to put in 10% of the atmosphere to be CO2.
But by number count or by mass?
100,000.
Sorry? What'd you say?
100,000. 100,000.
100,000.
Isn't
By number,
planet
the
params supposed to be by mass? Yes, ppm, yes, but in planet params, is
In
it also
planet params, it's
ppm or in kilograms?
It's not in
ppm.
It's in ppm. Because
So
that's
for GHG, it's in ppm.
Yeah, it's preformal.
it's how radiation is treated, so I'm not sure if it's ppm still.
So GHG treats it as uses ppm.
yeah, that's true.
So would it create an error? So like in the planet parameter file, you said 90% body blah in the right unit is N2. So if you don't put in 100,000 here, what is it going to assume for the rest of the constituent?
It almost certainly will not generate an error.
Most likely it will assume vacuum, basically. It's for radiation to treat, and it will just assume that you have something that has absolutely no radiative properties, no.
So effectively helium or something.
Yeah, something absolutely transparent. Okay, as I understand.
So the delimiter between these values is spaces. Does the number of spaces matter?
No.
As long as there's space.
But yes, it's your job to be consistent with the fractional distribution of your gases in the 2 different files and the molecular weight, the surface pressure, that stuff, because the model probably won't crash if you put it wrong.
It definitely won't crash. And it won't tell you that what you've done is incorrect.
And you have to be consistent, right, in GHG.f and also in the run deck.
Getting there.
Things like CO2 and stuff like that.
Yeah, we're getting that right.
CO2 and stuff like that determines the Rayleigh scattering.
Yeah, exactly. Those values.
CO2.
The P and the PN2 and stuff like that. In the planet params file determines the Rayleigh scattering. Exactly.
And the spectral file we're using needs to be consistent with the amount of CO2 we're using too.
Exactly. So we're going to look at that next.
It'll be down there.
Okay, I'm going to go back to, I'm in the Dex directory. Okay, so. Right. So there's my GHG file. I've edited the planet params file. And then Chris says here, by default, aerosols and ozones are deactivated in the planet run deck, and you can see that indeed they are all commented out here, as we expect. You can uncomment or change them as you please, of course. We should make sure that O3 is set to 0, which it is. CO2x is set to 1, which means take the direct value from the GHG file and don't multiply that by some number. All the other greenhouse gases are set to 0 in the GHG file, so I don't have to worry about defining them here. And I have to make sure I have O2x equal to 0, because I don't want the default 20% Earth oxygen showing up.
So for every gas, you can just add an X,
Yes.
which is recognized.
Yeah.
For every greenhouse gas.
Greenhouse gas. Okay. Regarding ozone, unless something has, I don't think this has changed in Planet 1.0, but if you use ozone, there are some issues with it, meaning that what we have here, as you can see, there's a default ozone input file. So if you use O3x equal to 1, so you want the default amounts of ozone, you then have to have an O3 file as an input file, and that CDF file. This is the default one for the Earth climatology, and you can see it's a climatology, meaning for years between 1850 and 1997. O3 has a seasonal cycle. So if you use this for a non-Earth world, you're going to get an Earth ozone seasonal cycle. So don't use ozone in this model the way it stands. If you want fixed ozone, I don't think we have that in Planet 1.0, if I remember correctly. Have we set a way to do that?
Fixed mixing ratio
Yeah.
like the other greenhouse gases? No.
Yeah, I don't think we have a way to do that. So you can't really run ozone in this model if it's not for Earth.
To generate a new input file.
You can generate an
You can generate a new file, that's right.
And Mike, I think you don't need O2x equal to 0 because you already set CO2 to 0 in Planet
It's
Param.
just a precautionary. I like to set them in.
Belt and suspenders.
What's that?
Belt and suspenders.
Yeah, belt and suspenders. Okay, anyway, that's about the O3 file. Oh yeah, and then Chris here again set all these things. I personally like to set these just to make sure the model knows not to use them, even if I've set them to 0 elsewhere. This should be 0 because I've set it to 0. He says, be careful when messing with these. Remember that PO2 was set in the planet params, and the greenhouse gases were set elsewhere. So, like you said, be very careful with using these things. Now, down to our spectral files. So now we've got a 90% N2 and a 10% CO2 atmosphere. Does that mean I can use the default GA7 spectral files?
No.
Yet. Definitely not. Those files will not be correct at all if we do that. So we have to go to our spectral files document, which should be hiding here. And we have to find one that suits our needs for 1 bar atmosphere. Let's see what we got here. Let's go up to the top and work. The Earth is not going to work, as I said. These more robust files will also not work. We have Archean Earth. Oh, only up to 1% CO2. That's not going to be useful. For 1 to 10% CO2, up to 1% CH4. These look like they could be useful. I think we can use these. And so we shall. So I have to use these spectral files. Now, as we said before, I have to be a little careful. In this case, I'm using a solar spectrum. I'm pretty sure it'll be in there in the shortwave, but let's double check that it's there. So you should all have this Model E support directory. You should have Socrates subdirectory in there, and you should have a spectral file subdirectory in there, and you should have an SP, SW, should be DSA_ARCC. If you look in there, you can see that, oh, well, we have a few options. We have a Proxima Centauri spectrum we can use. We can use our normal sun, and we can use our ancient sun 2.9 gigayears ago. Should we just try to do Proxima Centauri for fun, to do something different? So why don't we do that? PC. So we know it works here, so that's good. So then we go back to our run deck, go back to the spectral files where they're defined, and we have to change them. First, I also have to change these things This is a new run deck. Oops. E underscore.
Where are we changing this?
Well, you should have changed these because these are the paths to the spectral files. You have to tell the model where the spectral files are. And in the
right.
tutorial guidelines, we told you how to change these to a new path. If I could type, it would be much easier. Model support. Okay, so that should be correct. And then I have to change the name of these spectral files. So as I said, it's SP, SW, DSA, underscore ARCC, and then the name of that file, like that. And the long wave should be the same, DSA, underscore ARCC.
So what does the underscores LW and SW mean?
Long wave and short wave. I'm going to copy this again. If anybody sees any typos or errors, let me know. And then I'm going to change the solar spec to PC, Proxima Centauri, because if I go down to the bottom of the document, that's one of the stars that I can use. And these spectral files support the Proxima Centauri spectrum. So I'm going to get an M-dwarf spectrum. And these spectral files will allow up to 10% CO2 in an interplanetary atmosphere.
Your accuracy for this case is going to tank, though.
My accuracy for this tank is going to tank. For this case, it's going to tank. Why?
You said 1,500 watts per meter squared, and you've got 10% CO2.
Yes.
So you're going to be well over 310K.
Not when I run just the startup power. I'm still awake. Give me another hour. Okay. That's it for that.
In the Socrates folder, there's a lot of files with underscore K at the end. What is the underscore? Is that a K star?
It is the correlate, there's one file which is sort of the template of what's in it, and the underscore K is where the K absorption coefficients actually reside. And if I may follow up on Sunny's comment, the 310K, less than 310K accuracy that's carried through a lot is mainly because of what David did in the past, and I followed up with, is that not every file is validated against every single atmosphere we can think of. So as a simplification, the main template that is used is a Earth-like temperature profile at 310K at the surface with some Earth-like amount of water. Now, it is true that the more water-rich you get, in general, it makes it a little bit more challenging for accuracy, but it's not necessarily going to tank due to the radiative transfer from 310 to 360. You run into the too much water vapor in the atmosphere issue. But as a separate thing, I was going to show a slide tomorrow that I did take one of the spectral files and tested it against the Jim Castian saturated atmospheres out to 360K and saturated. And their radiative transfer does really, really good in those limits. So I would expect that the radiative transfer is going to hold well at 310K.
Okay.
Between 3 and 400K, then you get into high temp. But so I wouldn't, just because it says 310K, I don't think the accuracy is necessarily going to tank. I think that's just the kind of the standard validations we've done so far.
Remember, it says it's less than 1 watt per meter squared accuracy from less than 310K. It doesn't mean it's going to go logarithmic in accuracy above that. So if you go 20K above, it may only be off by 1.5 watts or 5 watts. So you have to ask Eric how far off it'll be for those temperatures.
And as a sort of follow-up about the CO2 amounts, there's the most spectral files reside under the general Archean heading, and we have up to 1% CO2, up to 10%, 10 to 20, 20 to 50. If you have a small violation of your CO2 amount, use 11% CO2, and it says up to 10%. It's still pretty good. We are pretty conservative about which file sets to use. Your worst violation would be if you say let's assume a Mars-like atmosphere and use the CO2 that's, or the Archean set that's only good to 1% CO2. That's going to give you your worst answer. But generally, if you're violated by a little bit, it's okay. But by the book, we recommend to use what's written on the page because those will give you, they are tuned to give you the most accurate results. But if you're lazy one day and don't feel like switching your spectral file and you want to try 11% and the file says up to 10%, it's not the end of the world. But that's strictly off the record, except for the YouTube, and now it's recorded on.
Realistically, we go a little crazy with GCMs about accuracy of the radiation.
Yeah.
You think about all the errors that are there and all the rest of the GCM parameterizations in cloud and convection and boundary layer, and even the dynamical core, sea ice and snow and everything. And so, as you say, if you're like a little bit out of bounds on the radiation, probably small change compared to the errors that are inherent in any GCM and all the rest of it.
Yeah.
Okay, let's try to finish this up. Then, of course, you can change your topography. You can change initial conditions file. We won't play with any of these, but they're all designed to you. And as I did say earlier, for model runs that we have published, most of them should, run decks and input files for those should be available on these web links that we mentioned previously. So you should be able to find all of these input files for associated run decks in our directory trees. So we'll just skip all that. He talks about bathtub oceans, so he provides directories to bathtub ocean input files that are residing on my directories on supercomputers. The same for aquaplanets. There's all kinds of stuff there. And let's go to the bottom of the file now, and let's change the run times here. I'm going to change this to 1950, so it runs a couple months here. I'll just leave the iStart alone, so it'll just do the startup hour, and that's it. Oh, then he has stuff about restart files. Yeah. So we could look at that too, just for fun. I don't think it's in here, though, is it? Do we have chaos? Oh yeah, we do. Okay. So as it stands, it'll generate one of these RSF files I mentioned before every 120 months. So every 10 years, basically. So we just use a default for that. And then he has some other things here, time step adjustments. Again, these are things that are all documented in this crash documents. And these commands he's giving here are things that are used for our supercomputer. But we don't need to do that. We're going to just go ahead and run the make setup. For this run deck that we created. Run equals this guy or girl. Hi.
You want setup run or setup?
Sorry, setup.
Setup. Yeah, sorry, not run. I don't know.
You want to run make clean for him?
Most of the time you don't need it.
Most of the time, yeah, you don't need it. Unless you've done a debug, you can call it debug before.
And this is a new run that you have never compiled it before, so there is nothing to clean.
Yeah, basically you have to clean when it has something to do with compiler or like changing like some important flags or something dramatic happens like if you upgraded your code.
Let's see if it compiles. Everybody should compile their code now, unless I want to hear all your fans going mad.
You're never going to mess anything up though if you were to do make clean, right?
No, you won't mess it up.
You just have to wait a little longer. You have to compile it.
That's true. You will never mess anything up.
Unless you've been messing with your make file, which we do not recommend.
Yeah, don't mess with the make files. Yeah, definitely not. Going, it's building. With my 4 cores. I can hear my CPU chugging away.
Did the NPS 23, that's for when it already submits it, or that's to build it with multiple?
That's to build it with multiple.
No, this is the hack. Usually you have to use like make -j setup, but there is a hack like to use setup dash run, and that will combine two steps at the same time. It will compile everything and then it will run it for the first time step. So those additional parameters are for the run that you want to.
Yeah, he has it. It says compile and cold restart in one step is what he should say, but
Got it.
I'm not doing that. I'm going to run them separately.
Normally, yes, I would recommend to do it separately.
And I have 4 cores, so I'm going to run those 4 cores, and I'm going to see what happens. And it's gonna, my firewall is going to tell me, do you really want these cores to talk to each other? Oh no!
When you're doing the module.
Oh.
The module?
I got the same error. I got the same error.
Yeah, then you have to zero out, like when you have
little bashes that load them all.
Actually, mine is a little bit different than his. Look at that. Aaron said the exit 1, but that line was different for his than mine. I don't know what that means. I don't know what that means.
and something else. I think.
And 12?
Maybe something. I remember it wasn't trivial.
Normally I add all these in my own run deck. Maybe I should go look them up in a run deck.
Yeah, I guess I have it also in my mind.
Could I request that this gets added to that tutorial document?
Hey, he's sitting down there. Chris. No, he's not. What? No. 11. Request.
Go ahead, go ahead.
Here we go. It's 11 and 12. And there's also these, I'm just going to add all these things. Why not?
While you're gone, we encountered the error, and it was requested that it be added to the tutorial document. What exactly was the error, Mike, that Chris needs to add?
CFC 11.x was set to a non-zero value, and so the model crashed. So you need to add a few more zero things, zero out a few more things.
Oh,
Yeah, it's because you're using non-standard spectral files. They don't have some cross stuff, and you have to zero it out.
Unfortunately, this means we have to recompile. Or I could edit the I file, but I'll go ahead and recompile. It'll be
It will be super fast. No, that doesn't. I mean, doesn't have to compile. I mean.
Oh, it's compiling. Mine is already compiled and submitted.
You're beating me? What? It's already compiled and submitted?
No, Jade's isn't compiled yet,
Oh,
so she hasn't gotten to the error yet.
Okay. Now it's running. After all these years of experience, I still screwed it up.
Getting errors, that's
The compiling.
good for tutorial.
Yeah, stop the compiling and edit the files. And I can bring it up again in another window. So that's a good one. See that?
Yeah.
That's a good idea. I made.
Oh, all of these.
Well, you need the CFC 11 and CFC 12. The question is whether you need the
And you need also this IGG
XG,
and
XG.x, and
Weird,
YG.
but we didn't put them in the GHG. So doesn't it already
So the
know?
GNG file only has 5 things, I
Yes.
think.
And
But there are
additional
the spectral
14
file.
in there.
buried in the
Oh.
application.
You really don't.
There are ways to change it in the source code, but we won't go there. Hey, mine finished. You guys are so far behind me.
XGGX.
Some other GHG file.
GHG files.
What? No. Under the CFCs. XGG.
Yeah, that's what I'm saying. Put those in too. XG.
Oh, yeah, but what?
There are other greenhouse gas
Oh, just random.
things.
Okay.
Yes.
Well, not random, but I guess we don't know what it is.
We ourselves don't know. If you've noticed, there's many things we don't know. I created my first file, and I can go ahead and scale ACC this thing because I want to take a look at it. see if Sunny's right and that the atmosphere is full of water. Okay, are you good? Everybody got that? Can I open this file? Okay. Let me just see what the temperature looks like for fun. And it's 11.9. Didn't change so much in that first time step, as one would expect. Why shouldn't exactly? And then we did. And then Chris did mention to check.
It takes so long to compile for us.
Say what?
It takes so long for compile. And then it's so
You can upgrade your computers.
Are you doing make minus J?
the what?
Do you do make minus J?
Make minus J?
Yeah. When you compile.
No.
It was on the command line.
Minus J, then you use a single core for compiling. With minus J, you use all the cores.
Well, I think that machine only has 2 cores as well. So.
Even that is twice.
I'm running on the supercomputer.
Oh, you
So you should totally do
You
make
should
minus
definitely
J.
use the J.
I am
That's right.
doing J
Oh,
actually.
you are?
Yeah.
Maybe your supercomputer's just slower than my little MacBook.
Well, sometimes yes, but
They were
usually they are,
University of
because
Chicago
frequently
computer.
they are. Yeah, because
Chicago needs to get their act together. I'm telling you,
They need more punch
Chicago has bad supercomputers.
well, the problem with supercomputers is that usually your file system is kind of remote because it's a distributed file system. So sometimes it's extremely slow. During the compilation, it's mostly reading and writing what the compiler is doing.
Okay.
So compilation is usually slower on
But it's,
local machine.
So one thing we can check, which Chris mentioned in his document, is the incident radiation what it should be? So here I plotted up INCSW_TOA from the AIJ file. You can see the mean value is 375. If I want to see if it's the value that I put in my input file, I multiply that 375 by 4. Somebody has their microphone turned on. Okay. So.
Got it.
Okay, thank you. If you multiply 375 times 4, you get 1,500, and that's what we put in the planet_S0. So it's consistent. At least I know I did that correctly. Okay, so look for consistencies between the output and the input. It's a good idea once in a while. Anything else we should peek at? I think there's not much else we can tell, only running one
Well, since
time
it's
step.
non-zero obliquity, I guess, you can see that it's non-zero, but you cannot figure out if it's 20 degrees.
No, we cannot figure out. Well, you might be able to
See where the maximum.
The maximum
Exactly.
is below the equator, so. But you need to know,
Well, maximum is, yeah, it's right.
you need to know for this month what 20 degrees means.
Yeah, so I can center on 180 instead. Max here, turn off interpolation.
I think this is just for a time step, but once you have monthly output, you could just plot the inflation over the seasonal cycle and see if it moves.
Wait, 6, I got the right value. It's minus 18, pretty close.
Oh, yeah, but that's not, well, I mean, depends on the time of the year.
It depends on the time of the year.
I agree.
How
First
can you do that?
Amount of work you put into it,
option, click.
amount of work you put into a homework.
Hear your product.
Let's discuss about that. Let me see your card reader.
No comment there. Okay.
Talk there.
Did we succeed? Some of you? None of you? All of you? You ready to go to sleep? The tutorial is about over. We have a few more minutes left before you're all free to go hit the bars or catch your plane, or both. Any other questions?
What are you looking at? Can you put that tutorial on the link?
It's a tutorial we put up. Absolutely.
Yeah, it will go on YouTube.
It'll take a few days, but we'll put it on YouTube as soon as our YouTube guru puts it up there.
Any questions online, Mike?
This man's in charge of the online
No
questions.
questions online.
Okay.
SRAT, what's the deal with that?
That's the specific heat at constant pressure over the specific heat at constant volume. So for a given gas mixture, you would basically follow the same rule of thumb for creating the molecular weight, but you'll have to do that for those variables and then calculate the ratio and put that number for SRAT, basically.
You should add a couple sentences to that document before you post it.
You have to have MER, SRAT, and kappa.
So kappa is SRAT.
Kappa is computed from SRAT. Kappa is computed
Okay,
from
so it's from SRAT.
Yeah.
So is there a third one? Or you only need those two?
You only need those two, as far as I know.
Just the mixing ratio.
And the mixing ratios of that,
Yeah.
of major of that.
You'll use,
So SRAT is the fractional sum of the ratios, right?
Yes.
Not the fractional sum of CP divided by the fractional sum of CV, or whatever it is, right?
It's CP for the gas mixture you have over CV for the gas mixture you have.
Yeah.
Right.
So you
It doesn't
you put the fractional thing.
It does not calculate that, no. You have to calculate that yourself. You have to get out your CRC handbook, whatever it is you want to use, and be careful, remember, now, all those values are temperature dependent. So pick a value for CP or CV that's close to where you think your temperature is going to be. I mean, it's not going to make a big difference as Sonny wags his head back there, but it's a good idea to stay within the bounds. Don't pick 450K if you don't think the model is going to go anywhere near there.
And either way, your model top with model bottom will have like 100 degrees difference maybe. So
Also, yes.
you need just be in the ballpark.
Yes. Try to stay in the ballpark, not way outside the ballpark. Yeah. Probably a general rule of thumb for this model. Okay. Good. Thank you all for listening. Bye from everybody here. Your only chance to say goodbye to the YouTube crowd. And good luck with your model runs. Hope to see you online. And we will share the Google Groups stuff to you in the next day or so. I'll put you all in there. And again, you can unsubscribe if you really don't want to ask your dumb questions there. Or your non-dumb questions, I should say, because there are no dumb questions in this model.
But you can listen to the dumb questions of others.
Everybody to use model E users or
No.
No, there is a Google group
No, we have a
for
Google Groups for the Planet branch. Okay, we will subscribe to these. There's some online.
yeah, there will have to be online. Okay, thank you everybody online.
Ciao.